Welcome, humanoids. Welcome to episode 3 in our course on the philosophy of climate change. This is a course where we try to think through the maybe the biggest defining challenge of the 21st century. As always, my name is Adam. I'm here to guide you through this, and I have Admiral Akbar here, my tech assistant. My son Max thought that he should get his own chair, so he made this cool cardboard chair. So he's off to the side here working the technology for us, sitting in his chair. It's good to see you all. In this class, we're going to talk about our method. So last time we talked about the Anthropocene. We talked about how humans are agents of planetary change, and climate change is maybe the biggest part of that dynamic. We came to realize just how massively big and complex this subject is, which raises the challenge and poses the question we want to take up today, which is, how are we going to think about climate change? How are we going to think through it? What is our mode of inquiry going to be if we're not just going to jump randomly here and there and grab things without any guidance? What's our method going to be? How are we going to get through this? So I want to suggest that there are 2 modes of inquiry into climate change, and we'll just very creatively call them mode 1 and mode 2. We're going to be doing mode 2 in this course, and so I want to spend some time in a lecture early on talking about that so that we know what we're doing. Mode 2 is problem-oriented inquiry, and so we're going to then turn to talking about problems, in particular this idea of wicked problems. After that, we're going to talk about questions, the role of questions. I think, and I know the good Admiral agrees with me, as Akbar always says, critical thinking is our greatest weapon. Questioning is super important as well, but should probably always be subordinate to critical thinking. So we'll talk a bit about questions and thinking as part of mode 2 inquiry. And then we'll kind of wrap up on the real world stakes of both climate change and philosophy, that this isn't just an academic study. This is about the way we live and what we should do. Okay. Now, I wish I would have known this at a younger age, but there is a whole community of people who don't necessarily do science, but they study science. They study the way science interacts with society, how knowledge is produced, the different forms of knowledges that are out there, the relationship between science and politics, or call it between knowledge and action. And these communities have different names and different methods, and it's a really rich, diverse group. These are just a few examples here where you might find this kind of thinking. It exists at the National Science Foundation. They don't just fund science, but they fund the science of science, or the science of science policy. In other words, how do we make sure the money we're investing in science actually translates into wise decisions in a better society? You've got whole academic communities studying philosophy, history, sociology of science. There's a big group that does policy studies that has to know how knowledge interacts with decision-making and politics. That's the world that we're kind of living in this course, and we're kind of making it explicit in this lecture. Let's get to this mode 1, mode 2 stuff. And I don't mean to create an absolute binary here, and I certainly don't mean to rank them like 1 or 2 is better than the other one. They're both necessary. I'm very much a pluralist, and there's a spectrum probably between these, right? So we're just going to try to make it clear by making a somewhat artificial distinction in this lecture. So mode 1 is academic, it's investigator initiated, and it's discipline-based knowledge production. Mode 2 is context-driven, problem-focused, and it's inter and even transdisciplinary. That is, it's a way of thinking between different specialties, and then even beyond specialized knowledge into society outside of the academy. Let me put these up here on a slide. And I'm going to give you different names, different ways of characterizing mode 1 and mode 2. And if one of them doesn't make sense to you, it's okay, because I'm really saying the same thing in different ways, just to try to get across this distinction here. Some people call mode 1 normal science, and some people call mode 2 post-normal science. So if you're really interested and you're digging in the literature, those are similar terms, okay? You don't have to worry about that. Again, mode 1 is a disciplinary form of knowledge production. It's where you're trying to develop expert specialized knowledge. Your community is your expert peers who are guarding the domains of this discipline, like the boundaries of it, and they're policing what's going to get in and what's not going to get in, who's going to count as a legitimate expert and who's not. Mode 2 is inter and transdisciplinary. It's trying to have communication across disciplines and across the academy to society. Mode 1 has its own standards of rigor. Mode 2 has its own standards of rigor too. Okay, it's very difficult to do Mode 2 knowledge production. It's also very difficult to do disciplinary knowledge production. I remember when I was in Boulder, I worked on environmental problems with the mayor, and he actually was a physicist, and so he had this Mode 1 knowledge, right? He was an expert in physics, but he said, you know, the problem with city planning and urban sustainability, that stuff is harder than physics, right? Because that's Mode 2 knowledge production. It's in the weeds of politics and values and all of that. He said, this is a really rigorous, difficult form of knowledge production that we're engaged in too. Here's just a different way to think of it. Mode 1 is basic research. You're really trying to make fundamental discoveries. Mode 2 is a little bit more like applied research. You're trying to figure out, well, what is relevant knowledge and how do we make knowledge relevant and how do we get it to help us solve problems? You could think of Mode 1 as being in the lab, where you set up parameters and you more or less artificially distill a kind of pure knowledge space where you're really focused on one little thing, right? And you're probing the depths of this little area. Whereas Mode 2 is a bit more like field sciences. You're out there where things are interacting and folding into each other, and you're trying to figure out all of these dynamics and relationships that are going on. A couple more terms here. Mode 1 is disembedded, so you're pulling something out of its context, historical, social, ecological context, and looking at it under these isolated parameters. And in a way, it's kind of infinite. You can always push deeper and ask another question. And there's always another peer-reviewed article that could be published about whatever you're studying. Whereas Mode 2 is more contextualist. You're trying to figure out how do we solve this problem as it really exists in the real world and not pulling apart and isolating it. And it's very targeted. That is, we're going to focus on this problem. We need to know what knowledge we need to fix this problem. We only have a limited amount of time and space and money and resources, so we can't do this infinitely, right? Again, Mode 2, if you want to put it in a nutshell, problem-oriented inquiry. That's what we're doing. To me, I know you all have heard of climate scientists. Super important, right, for climate change. Many of them, maybe most of them, do Mode 1 kinds of research. They're experts, they're specialists. Climate philosophers could also do Mode 1 kinds of research and really hone in on something. But we're doing climate philosophy as Mode 2, problem-oriented inquiry. Okay, think of them as shapes, right? Mode 1 is like these stovepipes, okay? Isolated, walled off. The walls are policed by this expert peer community, and they're trying to go deeper and deeper into specialized areas. Mode 2 is like a rhizome, okay? This tendrils and networks of rootlets and shoots that go up and cross boundaries and intersperse and tangle with these problems. That's the kind of shape of our thinking. That's going to be the shape of our method into climate change. And it's important, I think, because disciplinarity is great, right? But it raises the question of how do all of these specialties interrelate with one another, right? So somebody's got to be asking these questions and thinking through it. And we need something like Mode 2 so that we're neither trapped in our sort of specialist box, but neither are we wandering aimlessly, right? So Mode 2 will have these heuristics, these guides, these methods to do this kind of thinking so that you're not just wandering around lost. So we don't want to abandon the specialist's very focused, sharp vision for no vision at all, right? And that Mode 2 is a way to kind of travel, but not wander aimlessly. Okay, so it's problem-oriented thinking. What kind of problem is climate change? Well, I want to lean on this paper a little bit. It's a seminal paper in the kind of policy studies world that I mentioned earlier. And it introduced this idea of a wicked problem, okay? Tame versus wicked, okay? Or domestic versus wild problems. What they said is that in a tame problem, the solutions present themselves in a fairly straightforward manner as a broken connection to an end in view, right? So look at this top picture. You got a gutter that's been knocked out of place. That's a tame problem. Everybody wants that gutter to do what it's got to do to shuttle the water away from the house. You can isolate that problem, you can define it, you can locate it, you can solve it, right? That's a tame problem. It's a problem, right? The thing's broken, but it's sort of tame. Now the picture on the bottom is my cheesy attempt to represent a wicked problem. But it's not just that wicked problems are complex, right? Like this tangle of wires. And of course, this may not be a problem. Those might be working just fine, but it's supposed to serve as a metaphor. But the clashing values involved with the complexity can make it hard to define the problem, okay? And it can make it very hard to locate the problem. So from that paper, what they say is, knowing what distinguishes an observed condition from a desired condition, that's problem definition, that's hard. And then problem location, finding where in the complex causal networks the trouble really lies, that becomes really difficult also. So what is the observed condition, right? So actually, what is the state of the climate? That's complex. What is the desired condition? Well, people want different kinds of ideal futures, right? Do you want to live in big, clean cities, or do you want rural communities all over the place? So there's really fundamental clashing values about what kind of world we're trying to build in some ways. So given these two difficulties, Rattel and Weber, from that paper I'm citing, they conclude the problem of identifying the actions that might effectively narrow the gap between what is and what ought to be becomes practically intractable, right? It becomes almost impossible to figure out what is the problem and what are we going to do about it. So it's hard to settle on solutions. In addition, there's high stakes involved, right? Lots of uncertainty. And the science and the technology are woven into the ethics and politics, so the boundaries between what experts should be doing and what politicians or special interest groups, political groups should be doing are really blurry. Okay, so to sum it up, part of the problem is knowing what the problem even is. Okay, there's multiple interpretations of it. To quote Jen Rowland, a wonderful scholar who just completed her dissertation working with me, she writes in her dissertation about climate change, are carbon emissions a problem of corporate hegemony, the capitalist mode of production, poverty and income inequality, racism and colonialism, fossil fuel technology, or first world consumption? All of these at once, and each one could be described as a symptom of the other one. So there's no one right way of formulating, quote, the problem. She did a good job of summing up the wicked problem of climate change. Okay, back to this. I put this up, I think, in the first lecture. Most people aren't teaching climate change, and the biggest reason they say they don't teach climate change is it's not in their subject area. Well, the good news is climate change is not a subject or an area. Right? It's like this rhizome, right? This tentacles going around. Now you could, and many people do, focus on the part of climate change that crosses into your area of expertise. But that's not the only way to think about or teach about climate change. So you don't necessarily have to be like a Mode 1 scholar who has their turf and has to know exactly what's going on in their turf. You can be more like a traveler, wandering and following the tendrils of those rhizomes as they go along. And you're not forced to pretend to be an expert. Rather, you're a traveler, you're on the way of thinking, and you don't really have to so much have the right answers as you have to have good questions. And this is, by the way, for me, the Socratic way of thinking from Socrates. Okay, now I'm going to run through pretty quickly because I'm using up a lot of time here on this lecture, and I know we want to jump into it, but it's really important to step back first and say, how are we going to be thinking about climate change? Because again, otherwise we risk just sort of willy-nilly grabbing stuff and being led by biases or unexamined assumptions rather than some sense of systematic inquiry. So we know we're doing mode 2 inquiry, which is, for me, like philosophy, like these rhizomes shooting throughout the soil of climate change, right? And you've got these problems. Now, I've listed questions here using the traditional categories of philosophy. And you can look at those questions. And I'm going to run through, I've got 10 slides, one for each question. And we're going to go through just real quick, because the point isn't to delve into them. It's just to show you how questioning as a way of thinking along this path, along these rhizomes, can be really powerful, right? It can help you gain insights. It can help you unearth assumptions that are at work. You can see how metaphysical or aesthetic or ethical questions are underneath those assumptions, and how those issues are popping up in discussions, but they're often hidden behind scientific or technical or economic rhetoric. So this is the kind of insights we can get when we start asking questions in a mode 2 way of thinking. So again, let's just run through real quick one slide for each of these categories to see the kinds of questions we can start asking. Metaphysics, for example, what is the climate? So you could say the climate, and this is what gets tricky, the climate in a way is a scientific construct. We don't experience the climate. We don't directly observe it with our eyes or sense. We experience weather. So what is the climate? Well, it's long-term average weather. Well, what is long-term? We usually say 30 years, but in a way, from the perspective of the Triassic period, the Holocene, which is the last 12,000 years, is almost like a weather event. So it's squishy and tricky. That's not to say climate doesn't exist. It is real, right? Something can be real, but also a scientific construct. That's metaphysics, and it's at work in debates about climate change, although it's rarely raised up to this level of express discussion, but that's what climate philosophers can help us to do. That's what you can do. Phenomenology, how do we experience the world? I think this is super important in climate change. We don't experience the climate, really. I put this picture of a TV in a living room. All this stuff we consume, right? The economy that we're a part of, which is all those emissions that we're creating, those all have impacts on the climate, but those are distributed and diffuse and far off. And the glacier that you're contributing to melting is not there in your living room, right? And so this is a real big part of the problem, is that we're so disconnected from the impacts of the way we live, at least many of us, right? And this gets back to ethics and questions about privilege and position and climate change. Here's a big one, epistemology, the study of knowledge. What is knowledge? How is it generated? How is it validated? And really interesting, how could it be that some people disagree even though they've got more or less the same knowledge? This is a fascinating and important case study in the US, where you've got Republicans with high levels of science knowledge and Democrats with high level of science knowledge. And you think, well, if they have the same level of science knowledge, they should be on agreement. And this is where the most disagreement exists. Why is that? What's going on? That's going to be one of our questions. This is from hermeneutics, or the way we make meaning, the way we interpret complex realities and make sense of it. So it's not just a blooming, buzzing confusion. How do we do that? Really important. How are the numbers and the graphs and the models that climate science churns out, how are they interpreted? How do we make stories out of them that make sense, that we can find our identity in, that we can find a way of moving forward in? Also super important. Rhetoric, the media. Rhetoric is really about audience and framing a message. Look at the way Breitbart, scientists prove man-made global warming is a hoax. In NBC News, climate in crisis. Look at the way they frame this. Okay? And think about how important that is for public opinion and political power. Logic, making arguments. What makes a good argument? Under what conditions does it even matter, right? And probably not in Facebook comments, right? Doesn't matter how good your argument is, you're not going to change somebody's mind. How do you change people's minds? Right? So logic is super important. Religion. What's the deal with people's religious beliefs and where they stand on climate change? This is fascinating. And it's super important the way their deeply held beliefs can drive beliefs about climate and behaviors. So there's scholars out there studying this, and what they're finding is really important and interesting. So we'll talk about this too. So religion is part of it. Aesthetics, the study of beauty, of the way we feel the world, the way it flashes forth to us as either beautiful and attractive or ugly and repulsive. Wind turbines, right? So A lot of the resistance is people think they're ugly, okay, or they don't fit their aesthetic ideal of the landscape. What about ecotourism, going to beautiful places? Is that killing the planet, or could we mobilize that in a way where it's actually beneficial for climate? And I think ultimately you can make a case that art is more influential, more powerful than science in terms of getting us to grapple with and think through and live in the Anthropocene. Ethics. All of this in a way comes down to ethics. To me, that's where the rubber hits the road. You know, note how many times we said, well, how should things be framed, for example, with rhetoric, right? Or how should we make meaning with hermeneutics? Should we tax carbon? Should we stop eating meat? So all of this is coming together, right? So again, these aren't separate categories, ethics, rhetoric, metaphysics, religion. They're tangled and tendrilled together, right? And these are the kinds of questions that I think are popping up and then are underneath all of our climate change discourse. That's my dog. I don't know if you can hear her, but she's barking at something. Okay, finally, political science. Aristotle said that political science or political philosophy is the master science because it tells us how all the other sciences should relate to one another. And that's going to lead us into our next lecture because I think there's something really important about that. In a way, ultimately, this all comes down to power. Who has it? Who gets what, when, how, right? Whose voice is represented, who's not represented? Should rivers have rights? Okay, these I think are where all of this comes together. Who's responsible? What does justice look like? Big question. Okay, so what have we done? We've talked about how we're going to follow mode 2 inquiry. Mode 2 inquiry is problem-oriented. You're a traveler on the way more than you are a specialist in your own home turf. And one of the things you can take with you on your way is good questioning. And the categories you can use to help you with these questions are these sort of philosophic categories. But don't hold them strong and fast because things move and intertangle and we're just trying to move along with it. Okay, finally, a concluding question. Are we hypocrites? Okay, well, let me put it me. Am I a hypocrite? Look at this. On the right, more Americans say climate change is a major threat than they did in 2009. So percent of adults that say climate change is a major threat to the well-being of the US has gone all the way up to 60%. So, wow, you know, we got to do something about this. Then you ask them on the left, would you pay $10 a month in a higher electric bill to combat climate change? You know, maybe that's going to go to renewable energy or to a carbon tax or something, right? Well, no, we won't do that. So only 28% of us are even willing to pay $10 a month for something that we say is a major threat. So it's just to say, this is real. You know, you should be thinking through this course, what should I do, right? What's the right thing, not only to believe, but to do? That's philosophy. Philosophy is not an academic subject. It's not another box in the ivory tower. It is fundamentally about how I should live. What is a good life? What is a good society? How am I going to spend my limited time on this planet? I think climate change is the big issue that you can get involved in and contribute to. And you could say, I spent my time well. It's just, we want to know how to spend that time and be smart thinking through climate change. Okay. That's it for now. Next time, we're going to try to map our way through these problems on the landscape. And remember, as Admiral Akbar says, critical thinking is the greatest weapon the resistance has. Until next time, have a good one.